One of the things we learned how to do recently was to calculate the velocity of the center of mass of a system. And here's a reason why that might be useful. So this top picture represents maybe what a certain collision looks like if we were just watching it happen from, like standing within a lab or something. So we have this object A moving at a certain speed, running into object B that's not moving. And then perhaps afterwards, they both move forward at some other speeds. And again, I wouldn't know what these speeds are. That's what I'd be trying to find. What's kind of cool is that if we moved with the center of mass, if we could sort of find some way of following the center of mass speed and look at things in terms of that frame of reference, what we would see is a slower speed for A, so a smaller arrow, and B would appear as though it was moving backwards. After the collision, this is the key, what we would notice is that whatever this speed was here for A would be the exact same speed that A has afterwards, but in the opposite direction. And whatever speed B had to the left, it would have that same speed after the collision to the right. And again, this is if I'm looking from the center of mass frame of reference, this is what I would see. And so a strategy that we can use is to find the velocity of the center of mass and subtract that from our values of v that we know. So temporarily change our frame of reference. And then do the problem like this, which is just a matter of switching signs of our speeds, of our velocities, and then put that center of mass velocity back into our problem. Let's take a look at the problem we just solved using this method. All right, so we got the same problem here, our meatballs. What we have though is, or what I want to do instead of the way we did it before, is I want to calculate the center of mass velocity. So that means I need to know the m times v for each of the objects before the collision here, and divide that by the total mass. So that would be 2 times a positive 5, 3 times a negative 5, very important to keep track of your negative signs, and then divided by our total mass. And what we find here is that the velocity of our center of mass is -1 meters per second. So if we were to move backward at 1 meter per second as this collision were going on, it would appear like that other slide showed. It would just appear as though the two meatballs hit each other, bounced apart, and they whatever speed they went in with, that's the speed they came out with. So let's take a look at the 2 kilogram meatball. Its speed coming in was 5 meters per second in the lab frame, but in the center of mass frame, where we're moving backwards, if we take this 5 and we subtract the center of mass speed, this is how fast it would appear that meatball is traveling, because it's going to the right and my center of mass frame is going to the left. And my 3 kilogram object would appear, it's going at -5, it would appear as though it's going at -4. It wouldn't seem to be going as fast because we are going with it. All right, well, what happens is that after the collision in this center of mass frame, let me actually go ahead and do my after over here. After the collision, this 2 kilogram object will move at the same speed but in the opposite direction, so -6 meters per second. And after the collision, the 3 kilogram will move the opposite way, so it'll bounce off and move at 4 meters per second to the right. And then what I can do is I can bring it back to the original frame of reference. So here I subtracted the center of mass speed. Now to go back to the original, I'm going to add the center of mass speed. So I'll take -6 and I will add -1. And what we find here is that V1 after the collision is -7 meters per second. And 4 plus -1 after the collision, the second meatball is moving at 3 meters per second. So these are the same answers that you get using the other method where you set up a momentum equation and an energy equation, and you work through some algebra, or you maybe use your graphing calculator to solve that system. Both very good methods. You'll just need to choose one that you feel most comfortable with.